Why might we want to know the size of a particle, and how might we find this out?
The answer to the first question is a lot more simple than the second. The properties of individual particles tend to dictate the properties of the overall substance. Also, it's very useful to know whether every particle in a sample of some sort of substance is similar or whether there's a degree of variance between different particle species within the sample. Because if we have this variance, otherwise known as dispersity, it becomes very hard to make definite statements about a small portion of the sample that you do analysis on. One form of particle that it's very useful for us to know the size of is a substance known as a colloidal dispersion, and this is essentially a fancy term for solid particles dispersed in a liquid phase. Some everyday examples of colloids include milk, blood, ink, and mud. There are various ways of discovering the size of the particles, which is what this video centers around. One extremely commonly used method, which is found in industry and in scientific research, is the use of a laser to measure how much light bounces off particles as a result of their presence in a sample. This method is very effective apart from one problem. Larger particles cause a lot more light to bounce off than smaller ones, and in fact this scales with the 6th power of radius. To translate that into everyday language, if a particle is twice as big as another one in a dispersion, it will cause 64 times as much light to be dispersed, or in other words, it will take 64 times as many small particles to equalize the effect of the larger ones. Another method only discovered in 2008 is known as DDM, differential dynamic microscopy. This essentially involves the use of a microscope and some very complicated maths which takes the resultant movie you take of the particles. This method holds two advantages over the laser. One, that it is able to resolve multiple particle sizes in a manner that far outshines the laser with its problem with resolving two different particle sizes and to different ensuing diffracted intensity of light. And the other is that it is able to resolve particles which are actually smaller than the normal visible range, as illustrated in this diagram. This is obviously extremely useful as a lot of the particles we want to see in such methods are very, very small. Now DDM is very much in its infancy, so what remains to be seen is how long it will take for this method to take off and be used much more widely in industry, as it's currently mainly used in research, such as this project which has been undertaken. Thank you for watching this review video, which has acted as a public summary of my MPhys project. I hope it's been in some way useful and informative. And have a nice day.